Thank you so much to everyone who's joined us today. We will still have participants joining us as we start to kick off today's webinar. We're really grateful that you could have joined us today, so thank you. Today's content is really about gaining exposure to the booming semiconductor sector through the ASX. And welcome. My name is Andrea Culligan. I am the lead partner of innovation and venture building at Deloitte Australia, and I globally lead our emerging technology, connecting climate tech into industry. On behalf of Blue Glass and Share Cafe, it is my pleasure to welcome you to the second of our expert roundtables, where we are continuing to deep dive into global trends, opportunities, and challenges in the global semiconductor industry, while also exploring what Australia's role in this particular sector looks like decades ahead. In today's session, titled Gaining Exposure to the Booming Semiconductor Sector Through the ASX, we are turning our attention to the ASX's nascent semiconductor industry and, of course, Australia's growing role within the global $1 trillion semiconductor industry. And joining me today is a panel of very highly credentialed sector experts comprising of ASX CEOs and analysts. So it's my pleasure to introduce you to the panel. I'll start with Kobi Hanach. He's the CEO of ASX-listed memory technology developer Weebit Nano. Kobi has 43 years in engineering management, and exec roles in the semiconductor sector. Prior to Weebit Nano, Kobi was VP Worldwide Sales at Vericity, where he was part of the founding team that grew the company to over 100 million in annual sales, which also, of course, facilitated its acquisition by Cadence Design Systems for a whopping 315 million US. He was also VP Worldwide Sales at Jasper, doubling sales in 3 years before it was acquired by Cadence for 170 mil US. So obviously, Kobi has a lot of experience in starting and scaling businesses specific to this sector, with a lot of relevant experience as an executive. Scott Jeweler is also joining us. He's president and CEO of a semiconductor technology and capital equipment company, Revawsome Incorporated. And I love that it's called Revawsome. Scott has more than 25 years semiconductor experience across corporate strategy, tech development, and operations at industry leaders, Global Foundries, Mitsubishi Chemical Group, Amcor Tech, and Ultratech. He holds 7 patents and is the author of numerous articles on semiconductor chip industry trends and manufacturing tech. Thank you so much for joining us today, Scott. Of course, we also have James Walker, the executive chair of one of Australia's only vertically integrated semiconductor manufacturer, Blue Glass Limited. James is an experienced leader in commercializing technology in new markets, with exec and non-exec director roles at ASX listed and UK AIM listed companies, as well as other high growth businesses. He has over 25 years experience as a chartered accountant and company secretary of various high growth private companies. And he successfully completed the ASX IPO of the Dockyard and Drone Shield, and before that was the CFO of Seeing Machines, an AIM-listed company that utilizes advanced algorithms for detection of driver fatigue and distraction. Thank you for joining us, James. And last but definitely not least, we are also joined by Mark Kennis. He is the managing director of research firm Pitt Street Research. Mark has been covering the semiconductor sector as an analyst since 1997. You don't look that old, Mark. He obtained an MSc in economics from Tilburg University in the Netherlands in 1996 and a postgraduate degree in investment and analysis in 2001. And since 96, he has worked for a variety of brokers and banks in the Netherlands, including ING and Rabobank, where his main focus has been the tech sector, including semiconductors. And since moving to Sydney in 2014, he's also worked for several Sydney-based brokers before setting up TMT Analytics, an issuer-sponsored equities firm, research firm, I should say. So we have an incredible wealth of knowledge and experience and capability. Thank you all so much for joining me today. This is not a small topic, in particular the sector, and we have a lot of questions to put to our panel. But ladies and gentlemen, if you have a question for any one of our experts today, if you can please pop that question in the Q&A, and we'll try to get through as many as possible before or possibly at the end of the session. So definitely keep putting those questions into the Q&A box, and we'll hopefully get through them as we go. So we've got a lot of introductions out of the way, a lot of content, really excited to crack into it. Kobe, I'm going to start with you because I think there's a lot that you can bring to the table. And also I realize it's a very interesting time zone for you today. You're currently in Israel. I think it's about 1 a.m. We've got the team
Yeah.
sitting all over the world today. We've got Australia, we've got the US, we have Israel. So it's definitely a global view around Australia's role. And you are obviously very passionate about the need for Australia to invest in a local semiconductor industry. Tell me, what would a local industry look like? You're here a lot and you've also got this view from outside. So what would a local industry look like and what level of investment is required?
Well, first, thanks for having me here. Yeah, I think Australia has many similarities to Israel in the sense of size. I guess it's double the size of Israel, and but kind of culture, if I can say, is also kind of similar. And Israel, people often call it the startup nation. We have, I think, right now the count is about 8,000 startups in the country. And it's always surprising for me that I come to Australia and there is, hardly, I mean, it's not that there isn't any, and, we have Blue Glass, of course, and others, but it's rather surprising for me. And, I fell in love with Australia once I started traveling to Australia. And I really believe this is important. It's strategic. Today, semiconductors are everywhere, and a country that doesn't have any semiconductor activity, I consider it, even if I may say so, vulnerable to a certain extent, and it's just really important to feed this and setting up startups. I'm not talking about big manufacturing plants which cost billions. You need to start from something simple of just getting that going.
Yeah, I started my first business, and prior to Deloitte, I was a founder in and out of tech, and I started my first business in Australia in 1998. And there's been a significant growth since then in startups and in particular in the sector. But I really hear you. It's definitely got a ways to go. But in your opinion, how long would it take for Australia to develop an industry that is competitive globally? Because to your point, there is perhaps a sense of vulnerability when we're dependent on other regions to really bring innovation to us versus us create our own. How long do you think it would take?
The nice thing about startups is that, it's very easy to start setting up, startups. The government, obviously there needs to be government support here. So the longest thing maybe in setting this whole thing up is getting the politicians to understand how critical and strategic this is. But once they understand it, there need to be several laws passed to kind of enable this whole thing to start moving. Laws that enable the funding of the startups and give the government support that initial push. Once you do that, obviously you need to push the universities and all of the research institutes forward. But in general, it doesn't take that long to get the ball rolling. Then it starts growing as you go. And but I think you need to start. And the key point here is, I think some basic regulation. Even the way that ASX runs is counter startups to a certain extent. The whole way that the ASX works with options and RSUs, etc. It really, I mean, I find myself fighting things that are unbelievable. Just trying to get things moving. They're really counterintuitive for people who want to set up startups.
Yeah, and I'm sure every country has its challenges, but what I really heard from you there is around education, policy, mindset, capability, and there's a lot of tertiary education centers that are starting to take that on board. So it's good to hear that what you're saying, I can start to see in some ways. Next question I might pose to Scott. Scott, you've got a fair bit of experience around the US as well, and I'm keen to understand how much will the signing of the CHIPS Act stimulate the US semiconductor production to the sector, and how in particular can Australia harness this?
What's interesting, I think, obviously the amount of money that the US government wants to put into the semiconductor industry, after 33 years in this industry, it's kind of nice to see the government recognize it. I think they only noticed it when car production, was impacted, was probably what the trigger was, because that employs so many people in the United States. I think, to be honest with you, my personal view is that it's kind of open to be determined yet how that's going to affect the US. Obviously, some of the big semiconductor fabs, Global Foundries, TSMC, Intel are going after that money and are probably going to get a large chunk of it. The official grants aren't going to be stood up until February. And so what I'm curious to see is how much of the ecosystem, how much of that money goes into the ecosystem supporting those fabs. I mean, if you look at it at a very high level, obviously the government wants more companies that can produce, high-end chips for AI and for other processors. But, the reason why Taiwan and other regions have been so successful at manufacturing is because this complete ecosystem, which includes, materials, equipment manufacturing, small suppliers that do spare parts and consumables. And so, my hope is that when it comes time to actually allocate funds, that those portions of the industry also, are able to access funds. Because I think in the absence of that, you basically are just taking capital risk away from companies that are making money already, and you'll end up with overcapacity, and you'll create a worse problem than you have now, because you'll have more fabs that are not fully utilized or at a cost disadvantage globally. And I guess I'm still on the fence on how that's all going to work out for the U.S. I think for Australia, listed companies like Revosum that operate in the U.S. and listed in Australia, is an avenue for that, and to pull some of that higher level activity into suppliers and companies in Australia that can participate.
So do you think, and maybe are you already starting to see benefit then from the new legislation? Because what you're talking about is how do you look at what I'm hearing, I suppose, is the balance across the whole of the ecosystem to be distributed through the act. And are you then seeing some of the benefit as well, not just one area or other areas?
Well, so the actual grants are going to start in February. They'll stand up the applications in February. So we don't know yet. We expect to receive some money, and we've got a queue of projects that we're going to request funds for. But like I said, I don't know now, because our needs are small compared to these kind of high dollar projects to build actual leading edge fabs. I kind of think it remains to be seen how the money is going to be allocated and who the beneficiaries are going to be.
Interesting. Okay. James, Blue Glass has been involved in helping develop both Fed and state governments' commitment and focus on developing this enhanced sector here in Australia. But what do you believe needs to be done so that it is a more mature sector in Australia, and maybe even framing it like, what role does Australia need to be playing in order to develop a more mature sector?
Yeah, no, thanks, Andrew. So, I mean, we've been talking to the New South Wales government and the federal government for a while now. And if you look at the Australian sector, both previous speakers are right. There is no industry here yet. There are a couple of innovative companies with some great IP on a global scale, but there really isn't that collaboration. There isn't that interconnection. There isn't really a sector in Australia yet. And clearly that places Australia at risk. If you look at the supply chain issues over the last couple of years, governments around the world now doing the CHIPS Act or their equivalent in Europe, there is this real competition now that countries have to build their own industries, so they're not reliant on overseas countries as much as that we have been. And we need to do the same, and we need to do that fairly quickly. I think the question is where do we put our investment dollars? Where does the government focus its energy? Do we get the large companies to build fabs here? Do we focus on existing technologies that are being used in existing applications? Do we focus on the fabless applications, or do we actually invest in new technology areas where Australia can play a real role going forward as compared to catch up? And some of those areas I think are like compound semiconductors and even quantum computing, where Australia has a natural advantage already. So, we firmly believe that investing in silicon-based semiconductor industry is probably a little bit late. There are our partners, and if you think on a global securities basis, our global partners are well advanced in that industry, in that area, and for us to play catch up is probably not the best use of our money. But if we can invest in areas where we can actually have a global role, quantum computing is a great example, as is compound semi. We think that's probably a better way to go. And Blue Glass is really an example of that. So We're focused on gallium nitrate. We think that is definitely one of the areas of focus going forward. I mean, it's a leading candidate for all electronic performances in future applications. So we think GaN is an area that the government should probably focus on, because it will lead to a lot of new technologies going forward. And that's where Blue Glass is playing, and that's where we would like to see investment in an Australian sector to really build an industry here where we can not only just be self-reliant for our own needs, but have a role on a global stage in these new developing technologies.
Yeah, I think it's that where to play, how to win question and answer. Where do you play the largest part of that value chain? And it sounds, you've just spoken about compound and quantum, especially around GaN, and maybe that's something from a government perspective we really need to be considering, which is, Mark, where I'm going to hand to you. We've got the Australian Strategic Policy Institute. They've recently called for about a $1.5 billion investment in a domestic semiconductor manufacturing industry. Question to you, would a $1.5 billion investment enable Australia to be competitive globally if we were to really focus on those areas, given we're seeing significantly larger investments in the US, Taiwan, and Korea, and of course, they're very mature sectors. Do you think that type of investment would actually allow us to be competitive if we made the right choices, or do you think other things need to also be focused on?
Yeah, look, when I read that report, I thought, and it talks a lot about manufacturing as well. I thought, well, that's pretty ambitious on just 1.5 billion, right? Because the short answer to your question is not nearly enough. It doesn't even begin to cover what needs to be looked at here. But my biggest question around that report was, why would Australia need manufacturing in the first place? Because there's not a lot of manufacturing at all in Australia. A lot of that has been shipped overseas. Australia is really a country that imports a lot of stuff that uses semiconductors, right? So from that point of view, why would you need a domestic manufacturing capability, large scale that is, right? So I'm not talking about smaller sort of niche type things. So that for me is the starting point. Why would Australia need that? I think because this manufacturing is not really Australia's strong suit. Australia is good in a lot of things, but I think manufacturing, it's proven over the years that it's not the best at that. There's other countries that can do that better, specifically, I think for semiconductors, because you're starting with a 40 to 50 year delay, basically, right? Other countries have done this for much longer. And I think it was mentioned earlier, someone mentioned ecosystem. That is a critical element to getting an industry started in any country, right? So, and that's missing in Australia because there is a lot of research going on, and I think really that's, by the way, the essence of what Australia should be doing, which is R&D and IP building, intellectual property. I think that's really, and I think James alluded to that as well. That's where Australia should focus, not so much manufacturing, because you're way too late to do that, and there's no ecosystem. I think Scott mentioned all this ecosystem of small, part suppliers, consumables. It's really it's really a long road to go, and I think you'll be 20 years down the line before you got that set up. So that's a long answer to a simple question, really. So I think the focus for Australia should be on R&D. There's already R&D going on at the University of New South Wales in quantum computing. Some other universities are doing some stuff as well. I think if you focus on IP creation, IP generation in the longer term, that's really where that money is probably best spent going forward.
I love that response. It just comes down to, where is the focus, and then invest in the focus, and then where do you play across that value chain? So thanks so much. That was a great comprehensive response. Kobe, Weebit Nano is incorporated in Israel, but you've listed on the ASX, and you've also already spoken to the fact that it's a bit challenging at times. What made you to decide to list on the ASX over other stock exchanges or even VC funding?
So when Weebit started, and that was before I joined, actually, so it wasn't even my decision. But in Israel, there's a thriving startup environment, but the VCs have their preferences. And back in 2015, there was a big focus here among the VCs on cyber, AI, automotive, semiconductor, which used to be very popular, kind of fell out of favor. So we were kind of looking at how we're funding, and it was the ASX who realized more or less at the same time that there are a lot of mining and petrol or gas companies, etc., energy, And so they wanted some new technology. They sent a delegation over to Israel. Actually, several delegations came over. And today you actually have, I think it's about 20 Israeli high-tech companies listed on the ASX. So it's not just us. And yeah, it worked very well for us.
So really focusing where the clients are, right? So that's what I'm hearing
Actually,
there.
yeah, it's kind of funny because as we said, you know, there's nothing really for us except for that. And by the way, I think what Mark, if I can comment on Mark's input, you know, I believe that an investment by the government in getting the industry going in R&D, etc., that kind of gets the ball rolling, and then you have everything else that starts following. So manufacturing and so on will follow it. In Israel, to a certain extent, a lot of outside investments came as a result of all of the, you know, startups, etc., including manufacturing plants. But 1.5 billion is really a joke when you think about you know, a simple manufacturing plant costs more than that to set up.
Exactly. Scott, coming back to you, like Weebit, your operations are also offshore. What drew Revosum to list in Australia?
I think it's similar to Kobe's answer. You know, the venture capital markets at the time were really enamored with software companies. Hardware, which we do, is manufacturing hardware, capital equipment, not super attractive, and so it was a way for the company to access public markets, you know, at a smaller scale than you could do in other regions.
And you know, you're relatively new to the organization. How did, you know, being Australian listed, did it influence your decision? Did it detract your decision? You know, tell me how it.
You know, I've worked for both public and private companies, and you know, like most of you have gone through the private fundraising. You know, I think being on public market has advantages, both in terms of access to capital, and then also just, you know, forcing a company to go through regular audits and have financial compliance that's regulated. I think, you know, those are advantages, and that was attractive to me. I knew, at least when I was coming in here, that I wasn't going to fall into some, you know, something unexpected in terms of the way the company had been managing the finances. So that's positive for sure.
Yeah, definitely requires a bit of rigor and governance, which shows some stability in the business. I can totally hear that. James, Blue Glass has been developing and manufacturing semiconductor technology for about a decade and a half. What have you seen as some of the biggest challenges in this sector over that time?
Well, I mean, let me start by saying it's probably never been a more exciting time to be a semiconductor company in Australia than right now, because 10 years ago, most people didn't actually know what that was. So it's been a massive change in the time that Blue Glass has been listed. You know, so much so, as we talked about, you know, from a nation building perspective, we have to be less reliant on other countries. So we have to build an industry here, because semiconductors are used in almost everything we rely on today. So from an investor point of view, the more investors understand exactly where semiconductors play, where they're going to drive everything we rely on today, you know, there is a great opportunity now to educate investors about the semiconductor industry. I mean, we've touched on it, and why the ASX is a little bit difficult, can be a little bit difficult to deal with. They've done a great job in promoting themselves internationally as a place to raise capital for early stage technology companies, and Kobe touched on that earlier. Just the sheer number of overseas technology companies listed on the ASX is pretty significant. So, you know, the ASX is starting to get them. The federal and state governments are starting to get that this is an important sector, so they're starting to put money into it. I mean, it definitely starts with research, then moves on to startups, and then it has to move into an industry. So we're pretty excited about where that's going. You know, we've spent a lot of time starting to educate the market about the investment opportunity. This seminar is a great example of how Blue Glass is trying to lead in educating the sector on this, and we use obviously Pitt Street Research to put out some great notes on the sector, as do other companies. So we think it's a pretty interesting time from a semiconductor space on the ASX. I mean, the Blue Glass shareholders, I mean, we have nearly 5,000 of them, and they have been on our register, a lot of them, for a long time, and know our technology particularly well. I mean, most of our investor conversations are about our technology and how we commercialize it. Our investors are pretty highly educated about what we offer on the market. So we're committed to continuing the education process because we think educated investors, are a great way to help create the industry side by side with government incentives and government help. So, it's been a great journey, and we expect it to get more exciting as time goes on.
So what I'm hearing is it's definitely a industry and sector of interest. It still requires a bit of education with some of the investors to show the value in that industry growth. And those that have been in this sector or are starting to be in the sector have stayed around since that time. So that's great to hear there's some momentum. Mark, what does Australia need to do then to attract more companies that are part of this ecosystem to Australia?
Yeah, it's a good question, because that's what it starts with, I guess. How do you get these companies over here? And I think it's a chicken and egg situation, because the companies won't come if there's no local talent to work for them, right? And the other way around, the same thing. So it comes back to the point I made earlier. I think it starts with education in universities and making connections specifically with technical universities. Kobe alluded to how that's worked for Israel. We've had a similar situation in the Netherlands, where technical universities are really closely entwined with the chip sector. One company comes to mind, which is ASML, which is probably the supplier of the most critical equipment in semiconductor manufacturing. That was a nothing company in 1985 when Philips set it up. And it's the market leader in lithography right now. But that couldn't have happened without the support from a local technical university. And so that sort of flywheel effect is what you need to get going. And so that brings me back to my point. It's probably a good idea to start spending a lot of that money, the government grants, on education, and specifically developing these sorts of studies at universities, and then try to work together with companies, local companies, but especially overseas companies, to jointly build that up. And it's a long road, but that's really the starting point, I think. And of course, tax incentives will help for people specifically to get them over to Australia. Again, fringe benefits, tax incentives, but also maybe lifestyle opportunities, because Australia is a great place to live, which for some people is more important than money. So I think it's a combination of a number of things that could really get the ball rolling here.
Yeah, I think you've really focused a lot on that education and attraction to bring to Australia, and how we can, look at it from attracting people from a lifestyle and opportunity perspective, but we also need to support the uplift of capability in order to meet that demand if we're starting to look at it externally coming to the country. So really great intel there. I'm going to start talking about the markets now, and my next question is for Kobe. With the acceleration of digitalization and associated data consumption and storage, we've got a really exponential demand on advanced memory tech. Can you tell us about the global scale of the memory market today, and what in particular is driving that growth?
So you already mentioned semiconductors are going to be a $1 trillion market in the near future. Memories are the largest segment there. By the way, a side comment for the previous discussion, I sometimes show a slide which shows the top 10 market cap companies in the world. 9 of them are either semiconductor companies or heavily dependent on semiconductors, kind of to give people a feel for just what we're talking about. It's not a small, side segment. And so it's a big segment. It's $1 trillion segment. Memories are now the largest segment in semiconductors. Anything you do, you always need memory. When you turn on the machine, you want there to be a memory that software is sitting there and running. You have tons of data, and just think of all of the data gathering, if it's all kinds of sensors, if it's surveillance cameras, if it's all the videos on TikTok and Instagram and whatever. So this is a very big and very fast growing market. Even just the domain that we're in, which is non-volatile memories, and I won't go into all the technical stuff, but just the non-volatile technical domain is growing to be more than 100 billion US in the near future.
That's a fairly large scale size of the market. Where do you see Weebit Nano's role in that particular area of the memory market?
So I mentioned we're in the specific domain, which is called non-volatile memories. Those are the memories that don't lose their main data even when you unplug them from power, like a USB stick or something. So Weebit is developing a new kind of technology for this market. The existing technology, which is called flash, has been around for several decades, which is a lot of time in the technology sector. So it has quite a few limitations. Weebit's memory, just to kind of quickly mention, it's 100 times faster than Flash. It consumes just 1% of the power relative to Flash, and it's much easier to manufacture than Flash, et cetera, et cetera. So it's more cost effective. So we have a very good technology that's creating now a big buzz in the market and a lot of interest. And in semiconductors, developing a new technology takes many, many years, but we're now at the point where the technology has been proven to work. We did what's called qualification, which is kind of a certification process to get a stamp of approval that we are ready for mass production. And we're now in that process of moving to mass production facilities and actually starting to get there. So revenues are now very close.
Excellent. Well, congratulations. And it sounds like you're onto a very scaling space there. Scott, over to you. Revosym's wafer grinding and polishing equipment is designed for the silicon carbide market. Can you tell us about the advantages of silicon carbide over traditional silicon semiconductors and what applications are really driving that demand?
Yeah, I think the clear driver right now is in automotive. So typically for the end user, silicon carbide in the power chain gives about 10 to 20% longer battery life and reduces charging times by about 50%. So obviously that created a lot of excitement in the market, and the leaders in the industry moved around 2018 to silicon carbide devices, and now, as we were in this EV replacement cycle with internal combustion engines, that's growing very rapidly. But I think those same properties, if you think about the green economy, over time as the costs come down, we'll find them. That same technology will find itself into other applications. Anywhere where you're utilizing electricity, like to turn a motor, you can still save energy in the same way. So I think we're very much in the early stage. And I like James' comment. Silicon carbide is another compound semiconductor or high bandwidth semiconductor material, and those fabs don't cost $15 billion to build, right? They pattern at much larger geometries. They're more cost effective. So I think the Australian market, what James said makes a lot of sense, and it's a high growth. In some ways, it reminds me. The market that we're in reminds me of semiconductor industry when I first entered the industry, 35 years ago. There's a lot of opportunity for innovation. There's a lot of new companies. There's a lot of activity. So it's an exciting place to participate and to support.
So where do you think Revosym sits within this competitive market, and what are some of the things you're doing to differentiate?
Yeah. So like I said, we make grinders and polishers that are used to make the prime wafers. So primarily our equipment is used to make the blank wafers. They then go into a device facility where the devices are fabricated on the wafer. And it's interesting, in each of those markets, we have one giant competitor, who makes equipment for a variety of silicon applications and who kind of dabbles in the silicon carbide market. But the reality is that it has special requirements. So even if I compete against a $20 billion company, the amount of resources that he can take off these leading edge applications for leading edge silicon and allocate to this business is actually quite small. So it creates an interesting situation. We're a small company, but in many cases, I have more resources working on the technology than competitors who are 100 or 1,000 times bigger than I am. So there's a lot of growth. There's a number of companies, either integrated device manufacturers who are creating their own silicon carbide prime wafers, and then also kind of a merchant market for silicon carbide wafers that's really just starting. It's like 1 million wafers a year right now. It's growing at about 40% per year. So we see a lot of opportunity to ship our tools, into those customers.
Yeah, that's awesome. It's rev awesome. So no, I'm sure you've heard that before. Just just a reminder to the audience, if you had any questions that you wanted to put forward, please feel free to put that in the Q&A and we'll facilitate those questions as we go. Thanks, Scott. That was great. And pardon the pun, but I'm sure you've heard it 1,000 times. Thanks for humoring me with a laugh. James, look, Blue Glass is developing, as you mentioned, this blue and green gallium nitride laser diodes and are these laser diodes as prevalent as memory chips in devices and applications? And maybe also, if you can just help us understand, what are some of the applications that use these blue and green lasers?
Yeah, sure. So, I mean, laser technology is widely adopted in the industry today. It's used in the manufacture of virtually every advanced manufacturing material processing item, including semiconductor chips and memory. So it's used in the manufacturing process of those items and many other items. So it's used in the defense industry, battery power, AR, IR applications. So it's used in lots of areas today, electric vehicles as an example. So the laser diode market is forecast to be by 2025 a $25 billion industry, and the GaN laser sector within that is the fastest growing segment in the laser diode space, and it's forecast to be 2.5 billion by 2025. And as I said, it's growing faster than the other sectors. It's replacing existing technology because of the technical advantages it has, particularly in metal absorption, which is really important when you're doing that fine high-end welding, particularly in your iPhone or on chips or memory applications. So it's used in a lot of places today, and GaN is, as I said, replacing a lot of the existing technology. So, we're quite excited by focusing on that area. What makes it particularly interesting for us and why we focused on that area when we did a review of our technology about 3 years ago and said, where should we be focusing our energy? The GaN laser diode market was a space that there are few competitors. There are 2 large competitors in this space only. And what we're hearing from customers is they're looking for a supplier, a new supplier that is flexible on wavelengths and flexible on form factors. So we will be nimble and faster and have more variations of products than the current big guys today. So we're very excited to be focusing on that space today.
Yeah, I really appreciate you kind of sharing that, because I was really keen to understand how you would be competing in this very, established space, and how that agility would that be a hindrance or a benefit? But it sounds like your customers are really valuing the ability to be agile. Is it, am I kind of hearing that correctly?
Well, so in our first series of products, that's absolutely key. Our first series of products will be, which we're looking to launch fairly soon, just direct competitors, existing products out in the market today, produced by Osram and Nuclear. And our customers are just desperate to get a third supplier in there and happy to work with us as we develop those products. So alpha versions of the products out in the market today, we've just announced, a massive milestone for us, which is on the reliability side, which will lead, another step closer to products being launched. And then the future of where our unique RPCVD technology actually plays will be in the producing of green lasers. And we think our technology will have a unique role in the green space, particularly on the advantages of RPCVD over the existing technology today.
Love it. Now, if only Australia could also focus on the internet. James is cutting out a bit here and there. Sadly, we're not speaking about how we could solve that challenge, but definitely, I'm sure that'll be on our agenda in future sessions. Thanks, James. That's super helpful. And don't worry, we're getting across most of your content, but every once in a while, for those listening, there is just a small lag with James's internet.
Apologies.
Mark, now you've been covering the Australian semiconductor sector for a long time, numbers of years. How many semiconductor related stocks are on the ASX? And from an investor perspective, what do you think is the biggest misconception about the industry?
Yeah, so there's about 10 of them, I'd say, at the moment. And if you look at the investors in this space, there's basically 3 camps, right? There's team pump and dump, who think everything is a scam. You've got the true believers, people that, like myself, can really see these companies flourish, given some time, and because that's really what this sort of semiconductor development requires. It's time. And there's a whole group of investors that's really interested in this space. but needs more education, as in, like what James said. A lot of people know the technology that Blue Glass has, but that is probably not true for all companies listed on the ASX. They need more education. They're really willing to learn. They're clever people, but they just need to be a bit sort of educated on this space. And I think that's really where what the biggest misconception is, that that these stocks, because it's not sort of Australian, it's not native, so to speak, doesn't have a future here. I think that's the biggest misconception, because there's definitely risk capital. There's a lot of expertise already within these companies and in certain universities. So the misconception for me is that this doesn't belong here. I think there's a big future here for semiconductor related stocks. And I think if in addition to that, if you look at sort of other jurisdictions, Israel, the Netherlands have proven it, that education combined with public collaboration can really sort of take things to the next level. So.
Yeah, so it sounds like you scale one, you scale them all. It's not you don't shrink the pond, you increase the value for all once you start to increase the education, and then of course you're looking at the ecosystem and the investment within it. So that's really good insight. Kobe, Weebit Nano announced a lot of technical milestones recently, including qualifying your ReRAM memory technology with your development partner and receiving the first silicon wafers, incorporating your tech back from your commercial partner's US fab. Can you give us a sense of the importance of these particular milestones from a commercialization perspective? And when can investors expect to see a commercial product or perhaps a volume in production?
So, semiconductors, I often say it's the timescales used in semiconductors are months and years and not days. The process of developing the technology takes, a very long time. And we are really happy that we got to the point where the technology was working in the lab, was working when we did our prototypes. But the key milestone for us was qualification. Qualification is a process that's defined by a big standards body. They define a long list of tests that you need to go through. First of all, they say you need to go through 3 manufacturing cycles and take chips from each one of them, a lot of chips. In our case, it was about 700. Each one of them has to go through a very rigorous set of tests. So, and at the end, you show that the chips managed to survive after all of that torture, and B, that all of them worked in a similar way. There's repeatability, there's uniformity. So the things that you need for mass production. So we've gone through that. We've shown that we're qualified. It's true that we did it with our manufacturing partner, and so it's not a mass production facility yet, but their facility is just like any mass production facility. It's very advanced. We now entered qualification with our first mass production partner, which is SkyWater. So that's going to take us several months. And once we're ready with that, we'll officially be ready for mass production at SkyWater. So we're now already working with SkyWater to sign up the first customers for that. There's a lot of work going on there. Getting people to use the technology for the first time is always a challenge. Everyone likes to see that the technology was already proven on someone else's product. But it's, we're there. I believe that in the next year, we're going to see the initial licensing agreements. They'll be coming in, trickling in. So we'll start seeing initial revenues of license and NRE fees, etc. And once those customers will get to mass production, sometime in 24, 25, that's when we'll start seeing the royalties and things will really be ramping up.
Awesome. I love that the forecast is strong, and you've obviously got a roadmap that you're able to articulate, which is great. Scott, look, a quick question. Revosum's wafer equipment already supports very large 200 millimeter wafers. When is the silicon carbide market expected to transition from 150 to 200 millimeter wafers, and what impact do you think this will have on market adoption?
Yeah, so there is some 200 millimeter silicon carbide production today. I think the challenges really get down to producing high quality boules, which is what the wafers are sliced out of, with a defect density that makes it cost effective. And I think because the end demand is growing so fast, a number of our customers will produce as much 6-inch product as they can while they bring up the yield on the 8-inch wafers. So I think the key thing is really when you transition from the bulk of the volume being on 6-inch to when it moves to 8-inch. And I think that's going to be probably the 2024, 2025 timeframe, but there will be a ramp, and it's occurring at a slow rate now on 200 millimeter, and will continue to accelerate over time. And the impact for us, in grinding, we participate both on 150 and 200 millimeter wafers. On polishing, there's some legacy technology, these batch polishers that can accomplish what's necessary cost effectively on 150 millimeter, but don't work on 200 millimeter. So that transition to 200 millimeter will drive kind of the next stage of our growth, which will be on the CMP side, the polishing side of our business.
Awesome. And Mark, I want to just ask you another quick ASX question, because these last two responses have really been about growth and scale and a really clear roadmap. What do you think these ASX listed semiconductor companies need to do better to appeal to Australian investors? I know we've spoken about education, but what do you think that these organizations need to do better in order to appeal to these investors in Australia?
Yeah, look, it's a good question. I think the education, again, is one of the things, but explain the technology. We spoke about that already. I think the other things that they could be doing is talk about the longer term, right? Not just what's being done at the moment and what sort of process you're going through. Because it's in my experience, Australian investors are a little bit impatient, looking for the next announcement and the next announcement, and when's revenue coming, and those sorts of questions you're not always able to answer properly as a developing company, but trying to paint that longer term picture. If we do this, if we do that, and this is, these are the steps at a certain point, and without being too specific in terms of years, because even things can go wrong or take longer. But try to paint that picture, what revenue models look like potentially, and how that would sort of work, how that would develop. It's sort of similar to a mining company where you drill a hole in the ground, see what comes up, you qualify that. But investors want to know, okay, so what's next? When can we, when is it going to the mill? When can you ship this, etc. So it's the same for tech companies, and I think because of all the uncertainties around development of this sort of technology, it's hard for companies to be specific about it. I get that. But at the same time, that's probably what investors are looking for as well. And a lot of investors don't want money today. They're happy to wait it out, but it's good for them to get that sort of longer term picture painted to them. So it's easier for them to stick with the story longer term, because the worst thing that can happen for these companies is that investors lose interest, sell their stock, and share prices come down, which makes the funding exercise in the next round a lot more difficult.
Yeah, and of course, that short-term, long-term pathway is really important for investors to understand the value of what they're investing in and the organizational capability and growth plan. But Kobe, Weebit Nano is also known for having a world-class board of industry luminaries, and we also know that boards are very reflective of investor appetite. How did you go about attracting this top talent and the expertise at management and board level? And I mean, I've just stated as perhaps it's important, but how important do you think it's been, or it is?
I think it's critical. I think at the end of the day, having a strong board and a strong management team is really the secret of successful companies. And I'm very proud of my board. When I joined the company, one of the things that attracted me to Weebit was knowing that Dadi Perlmutter joined a little bit before me as chairman. I said, if this guy, the guy that invented the Pentium processor, sees value in this company, I guess there's something there. And so I took a closer look. And then both of us went about once we saw the real potential here, and we were very excited, we talked to our friends, and so we brought on board both Atik and Yoav, who are really industry luminaries, and so it's great to have such a board. Atik and Yoav both were CEOs of large companies traded on NASDAQ. They know the public markets. All three of these guys with Dadi, they know the semiconductor market. Each one of them has even more experience than I do in semiconductors, and so it's among the four of us, you have way over 200 years of experience already, and that's critical to avoid issues. And people were asking me about competitors and so on. I think one of the reasons Weebit is where it is and our competitors are where they are is thanks to this board.
Yeah, I think that just talks to the criticality of top talent and experience really coming to play in order for success. James, a quick question to you. 20 years ago, Australia established the Australian Microelectronics Network to develop the semiconductors ecosystem, but 5 years later, they cut the funding instead of holding on for the long term. Australia should stay, obviously, the long term, if it wants to play a part and protect its sovereignty and talk about vulnerability. But why do you think now is different?
Well, I think you've only got to look at the last couple of years to see that now is different. So we touched on earlier in this conversation, no one's ever had to wait 6 months for a car before, as an example of where semiconductor industry is critical for our general way of life. So, and then you've got the tensions in the world, particularly in our region, and where most of the semiconductor industry actually is. So thinking about that, and thinking then about what's happening in regulation and government incentives around the world, Australia can quite quickly fall behind if we don't start to build our own industry here. And as I touched on earlier, I think picking where we should be playing is probably just as important as as the decision to create an industry. So that's the real question in front of us. But we have to start building an industry here and building the talent. And as most of the speakers have said today, there isn't a lot of talent here so far today. And that led to Blue Glass, for example. We acquired a fab in California in April this year, because in our manufacturing process, we had the capabilities for the first part of making a laser diode in Australia, but we could not do the rest of the manufacturing process ourselves. The technology, the resources, the infrastructure didn't exist in Australia. So people will be happy to know that we bought a second-hand existing fab for $2.5 million US, as compared to some of the billions and dollars that have been talked about today. But if we were to build a brand new fab today for laser diodes, it would be about a $40 million investment, to put it in perspective. So once again, to my point, where do we invest our money where we can get the best bang for our buck? So we were quite fortunate with the team that we've now put in place at Blue Glass at both the board level, with Jean-Michel Pellipat joining us, one of the founders of Nibiru, one of the leading laser diode companies, and then Jim Haddon joining us as president in September last year, a 35+ year industry veteran based on the West Coast. With them joining, that then gave us the ability to attract further talent and actually the infrastructure to complete our program. So, we had to invest overseas because that technology doesn't exist today. Fairly hopeful, though, with the New South Wales government and the advanced manufacturing sector being built out in Western Sydney, that there is some potential to bring that back and some of those processes back to Australia. But it was critical for our own journey as a company that we build those resources in-house now, and that just happened to be in the US.
Yeah, and it's such a good point. And I love that, you talk about the value of how do you look at legacy assets and redevelop them in order to look at future capability. But Kobe, I'd love to know your view. You've been in the industry for, I think you said 35 years. I'd love to know, we've had this kind of short-term thinking in Australia around the Australian Microelectronics Network, around the ecosystem. Now we're looking at staying the long term. Why is this time, in your viewpoint, different?
Well, the world has really undergone a huge transformation over the last 10, 15 years. And I refer to a slide that people really liked, I think, in my presentation. 10 years ago, there was only one semiconductor company among those top 10 that I mentioned earlier. You used to have all these petrol and financial companies in the top 10 market cap companies in the world. Today, it's the Facebook, Google, Amazon, et cetera, and by the way, all of these guys have pretty big semiconductor development in them. You know, that's not their main activity, but they can't ignore it. So the market has changed. I think Jim talked several times about the fact that, you know, practically anything you touch today has semiconductors in it. You look at cars, the new cars have hundreds, many hundreds now of semiconductor components in them. Just think of all of these little sensors, you know, that you stay in lane. What's the distance from the car in front of you? You touch the handle of the door and it unlocks the car, et cetera, et cetera. There are a million sensors and everywhere, anything you go. Of course, you know, people think of cell phones and laptops, but it's just all around us. So and you know, just to touch the point, Tesla a year ago had a recall of 160,000 cars, and people, you know, intuitively think that it's the motor, it's the braking system, it's whatever. But no, it was the non-volatile memory stopped working. They wore it out, and you know, it's that kind of thing. It's everything's becoming, you know, semiconductor computer, and that's where we are today. We're at that point where you cannot ignore semiconductors because you can't live without them. They're all around you. And it's really time to invest. And you can see even the geopolitical tensions are now a lot about semiconductors. You know, the whole issue of Taiwan is, you know, the number one reason why people are talking about Taiwan so much. Unfortunately, it's not because of the Taiwanese people, which, you know, it really hurts to say that, but it's the concern that all these governments and everyone has around what's going to happen with TSMC and UMC and so on. So I think it's really time to take a much closer look and to understand this is very strategic for governments.
Yeah, you know, focus time is now. And of course, we've had challenges with supply chain. We've had a challenge with talent. And Scott, I've got just a final question perhaps for you. We've got a lot of university students coming in from overseas. Does pushing money into university only give, again, our point to investment into overseas development? And how do you also then look at Australian students and sovereign and IP capability in Australia being kept here? What are your thoughts there? It's come from the chat.
I mean, I think it's a matter of focus, and I think you know, I agree that the way for Australia to enter into semiconductors is through technology and innovation, and a great way to do that is through the universities. You know, obviously, you know, it's not only training students, but building programs that have students that are overseas students and local students that then can take those ideas, whether they came from somewhere else or were born in Australia, and then create businesses and industry from that innovation. And I think that's a great way to incubate, you know, an industry in Australia, given where the country is now. And you know, not every part of the semiconductor industry requires $1 billion to get started. You know, there's startup design firms. India's created a huge chip design industry. You know, there's other segments of the industry. We talked about compound semiconductors or quantum computing. Those are areas that are ripe for innovation, and you know, with money and smart people and resources, I think that can be made to happen.
Thanks, Scott. Mark, I have the final question going to you, if you can do this in 30 seconds or less. But what can Australia learn from other semiconductor jurisdictions? Give us the top couple of points.
All right. Well, in 30 seconds, you can't go it alone, as China has tried to do, investing 150 billion. What it shows now with the US basically cutting them off from leading edge technology is that you can't do this alone. And Australia is well connected in the world, right? It's got crucial partnerships with the US, strategic partnerships, as you said, the US, Europe, Korea, Japan. So there's a lot of sources to draw from, and you have to work with these countries, basically, not just companies within these countries, but the countries themselves. So I think the main lesson here is you can't go this alone. You have to build it up from scratch. And in the case of Australia, start with education, but really try to incorporate all these partners that you have already, because there's a lot of goodwill, I think, towards Australia in the world. And I think you should use that for this industry specifically.
Mark, perfect finish to today's webinar. Thank you so much for all of your insights and expertise that you've shared with us today, panel. It's been a very stimulating discussion. I'm hearing things around it's time to invest. How do we make sure that we're educating and empowering not only our investors, but the ecosystem and talent and capability. focus on where Australia is going to play and where we're going to really lean in. And of course, last but not least, Mark leaving us with definitely don't go alone. There's an opportunity to really empower the ecosystem. Thank you so much to the event organizers, Blue Glass Limited and Share Cafe, for bringing this event series together. We look forward to bringing you on our next expert roundtable highlighting the future of quantum computing and Australia's role in the quantum revolution. And most especially, thank you so much to our audience and our panelists today. Thank you again, and we look forward to seeing you again next time.
Thanks, Andrea.
Thank you.
Thank you.
Thank you.